a bisection method. We have considered the introduction of bisection method. So we have an example on how to solve a bisection method. Find a root of the equation x to the power of 3 minus 2x minus 5 is equal to 0 using bisection method up to 6 successful approximations. We want to solve this algebraic equation using bisection method. So let's start with iteration, and I explain iteration that we are going to put at x is equal to 0 so that we can get our what? Our root interval that lies between that is the root that lies between that is the opposite side, the negative and positive, that negative and positive or positive and negative. So our f of x is equal to x to the power of 3 minus 2x minus 5 is equal to 0. So I'm going to have x of 3 minus 2x minus 5 f of x. So my first iteration, I'm going to make s at s is equal to 0. So I'm going to put f of 0 equal to 0 to the power of 3 minus 2 0 minus 5. So I'm going to have 0 times minus 2 0 minus 5. At s is equal to 1, f of what? F of 1 is equal to what? 1 to the power of 3 minus 2 into 1 minus 5 is equal to what? 1 minus 2. That is 1 minus 2 is what? 1 minus 2 minus 5. 1 to the power of 3 is 1. Minus 2 minus 5. I'm going to have what? Minus 6. So at s equal, my first iteration at s equal to 0, I have negative. My second iteration at s equal to 1, I have what? Negative as well. And when I'm dealing with this iteration, it means we have to consider, we have to consider two things, that is two numbers, where it lies on negative and positive or positive and negative. If I take at s equal to 0, I have negative. The opposite of negative should be what? Positive. Suppose this is positive, I will take this, but it's still negative. I'm going to what? I will continue doing my iteration at when I arrive is either negative and positive and what? Or positive and negative. That is, if this one is negative and I get my opposite of negative is what? Positive. So I stopped. Since I've not get it, I'm getting negative and negative. So I'm going to test, continue my iteration. Consider at s is equal to 2. At s is equal to 2. So I have f of 2 is equal to what? 2 to the power of 3 minus 2 into 2 minus 5. It means this function, I'm going to put 2. 2 is power of 3, which is 8. That's I'm going to have 8 minus 4 minus 5, which is what? Minus 1. So since I also get negative, this should be what? Suppose, since this one is negative, my next should be positive, but I did not get positive. So I have to make it, I have to what? To keep doing the iteration. So I'm going to consider at s is equal to 4. At s is equal to 4. So I will have f of what? At s is equal to 3. I'm going to have f of 3 is equal to 3 to the power of 3 minus 2 into 3 minus 5. So I have what? I'm going to have 3 to the power of 3, 27. 27 minus 6 minus 5. That is 27 minus 6 minus 11. That is 27 minus 11, which is what? 16. You can see that I have positive here. So I will now go to more. So the next, before f of 3, I have what? F of 2. And f of 2 give me what? Negative. And in bisection method or bracketing method, bisection method is also known as bracketing method. I must what? First thing is what? I have to what? I'll first do my iteration. And for that my iteration will not determine where I'm going to get my real root, which lies on. So since this one is negative and f of 2 is negative here, f of 2 is what? Positive. So my root lies on what? Minus what? F of 2 and what? F of 3. That gives me negative and positive. Suppose if this one is what? Negative again, and I do f of 4, if it is positive, I will take this one and f of 4. But I've gotten positive here, and my last, and before my positive, what did I have? Minus 5, minus 1, which is what? Which follow f of 2. So since f of 2 is what? Negative, and when at s of 3, f of 3 is what? Positive. So the root lies between, So what give me negative at s is equal to 2? 2 and what? 2 and what? 3. So for me to get my first approximation, this means this approximation I'm going to do x1, x2, x3, x4, x5, x6. So I'm going to have, like, if I have Sn like this, that is Sn like this. So n is equal to 1. I'm going to have x1 till x6. So I have to get what? I have to get what? For me to get my x1, I'm going to have x1 is equal to the I have to find the midpoint. Yes, what's give me positive, which is 2. The addition with what? What's give me what? What's give me negative is 2. And what's give me positive is what? Is 3. 2 of 3 all over 1 and 2. That is what? 5 divided by 2. So I'm going to have 5 all over 2. So 5 divided by 2 is what? 5 divided by 2, I have 2.5. So my x1 is equal to what? 2.5. So I've solved it. So I want to do what? I want to do my second approximation. For me to do my approximation, I have to substitute this into this function that I'm giving, into this algebraic function, so that I can get my words. So it will not determine where to take my word midpoint, and I get my h2. So f of x is equal to what? X to the power of 3 minus 2x minus 5. So it means if f of this is equal to x1, I'm going to have x1 power of 3 minus 2x1 minus 5. So it means what is my x1 is power of 3? 2.5 all over 3 minus 2, 2.5 minus 5. So 2.5 to the power of 3, 15.625 minus 2 times 2.5, which is 5, then minus 5. So I'm going to have what? 15.625 minus 5 minus 5. What did I have? I have 5.625. So I have f of x1 is equal to what? 5.625. Once I get my first approximation, I'm going to substitute my first approximation answer into that function I'm giving. So, and I substitute it here, and I got this 5.625. So the reason why we are doing this was, we know this is what this will determine this will determine where to get our root for, so that we can get our midpoint. And for us to be doing that midpoint in bisection method or bucket method, we will be getting for h2. So it means what's giving this? This is positive. That is positive sign. Invisible sign is positive. So it means I've gotten my what? I've gotten my first midpoint here. That is a midpoint value. So I have to go to what? My last positive. I have to go to my, so what is my last negative? So here, what's my last negative here? My last negative, f of something that I have negative is what? Minus 1, which is what? F of 2. So I'm going to have, since f of 2 is equal to negative, and f of x1 is equal to what? 5.625. So the root, the root lies between f of 2 and what? F of 2 is positive. So what gives me this? So I can write like this, f of x1. That is, what gives me x1? 2.5. 2.5 is what? Positive. Because x1, this is f of x1. Let's write this 2.5. Because when I substitute 2.5 into that function, I have this. So it means I'm going to consider positive and negative. I'm going to consider what? Positive and negative. So it means this is what? Positive here. This is what? Positive here. And my last negative, that is my last one. This was my last negative is what? 2.5. I will go to my last negative, which is what? F of 2. F of 2. So I'm going to have 2 plus 2.5. That is our midpoint. So our midpoint will give us what? S2. 2 plus 2.5 all over 2. So I'm going to have 2 plus 2.5 is 4.5. 4.5 divided by 2. 4.5 divided by 2, I have what? 2.25. That is my S2 is what? 2.25. So I have to get my root lies, where my root lies again, so I can determine the midpoint for me to get my S3. And we are told to do what? To do what? To see successful approximation. And the aims of solving using bisection method to solve any algebraic equation or non-linear algebra is that at my last answer, I will keep doing it. See, my last answer, my last approximation, that is my approximation should give me 0 or sufficiently small. It's converge. You can say 2.25. This is what 2 point, that is S2 is what 2.25. It's not equal to 0. So I will keep doing my approximation till I have 0 or something that is sufficiently small, which is 0, that is something equal to 0. Is it 0.01, 0.00? But I must have what? 0. So if I have 0, it means what? I have what? My rule, which is what? 0, which obey the bisection method or bracketing method. But since we are told to find 6 successful approximation, I'm going to stop at what? 6, S6. So for me to consider my what? My S3 approximation, I have to put this one into my function, which is this. I'm going to have f of x is equal to s raised power of 3, f of x equal to s raised power of 3 minus 2x minus 5. So when our s is equal, if our s is equal to s2, something like, I'm going to have s3 minus 2s minus 5. So it means whenever I see x, I put what? 2.25. 2.25 to the power of 3 minus 2, 2.25, then minus 5. If I solve this throughout, what am I going to have? 2.25 to the power of 3 minus 2 times 2.25 minus 5. So I have 1.89, 1.890625, 1.890625. So is this. So this my f of x will now determine where my root lies on. So this is what? The visible sign that is there is positive. So it means I have to go back to what? My last negative. So my last negative still fall on what? -1. My last negative that I consider is what? Still fall on f of what gave me negative that time is what? -1. So what gave me -1? F of 2. So since f of 2 is equal to negative, it will be my first root, and my second root is this, which give me positive, and f of s2. So what is s2? That is what? F of what? 2.25, and f of 2.25 is what? Is positive. You can make screenshot for this. This is 6. So the root lies on what give me negative? F of 2 give me negative, that is 2 and what? 2.25. 2 and what? 2.25. That is f of 2 give me negative. So I'm going to do 2 plus 2.25 for me to get my S3. So it will not determine my S3 divided by 2. So I'm going to have 2 plus 2.25, 4.25, 4.25 all over 2. So I have S3 is equal to what? Divided by 2, I have 2.125. 2.125. For me to get my S of 4, I have to get my mean root, where my root lies, that is the negative and positive. So I have to put this into function they are given as f of x is equal to what? S to the power of 3 minus 2x minus 5. So I'm going to have f of this. It means whenever I see x, I put s3, which is this 2.125 is equal to 2.125 to the power of what? 3, then minus 2, 2.125 minus 5. So I have to the power of 3 minus 2 times 2.125 minus 5. So I have 0.345703125. This is what I have. So it means I've gotten my f of this function. So this my f of my last f of this will now determine where my real root lies. Will now determine where my what root lies. That is, my root lies in this. So what gave me this? When I put that function of s3, f of what? 2.125, I substitute it into that algebraic equation. I have what? 0.345703125. So I have positive. So it means I have to go back to what? My last negative. And here's our what? you can see that here is what our last negative here is what f of 2, which is what negative, and our last negative here is what f of 2. So it means I'm going to consider, since f of 2 is equal to negative, and what I get here, and f of what 2.125 is what positive. So the root lies in, so the root lies in, the root lies in between, the root lies in between what? The root lies in between 2 and what? 2.125. So for me to get my S4, so my S4 will now be my, remember that when I'm talking about this bisection method that time, in our what introduction, I said a plus b all over 2. So it means my first positive plus my negative, that is my negative plus, or my negative plus my positive. This is the root lies. So our first root lies is what? Last, which I get negative, which is not to first. And my what? Next positive is what? Next value is what? Is b, which is what? 2.125. So a plus b over 2 will now be 2, it stands for a, and b stands for what? 2.125. So I'm going to have 2 plus 2.125. So this function is just showing where I got what? Where my root lies, that is the negative and positive. So we are not considering our answer for this. The f of what we do that give us that answer, which is positive or negative, will determine our what root lies, which we are going to get our midpoint. And when we get our midpoint, it's not our what? Our midpoint, that is the root lies between the negative and positive, which is what? A plus b, which is what? The negative, first negative, and after negative, the opposite of negative is what? Positive, divided by 2. I'm going to have 2 plus 2.125 divided by 2. So I have what? 2.0625. So I have to get my what? Since the question said that what? To sixth approximation, so I have to check for my what? 6, x6, x5. So I have to do for my what? x5. So for me to get my x5, I have to get what give me x4. That is my fourth approximation to that function. This is just the step that we'll be doing when we are getting our approximation. It's a techniques. Since we'll be doing that, we'll be getting it till we get what? Till we get to what? Sixth approximation. Or if the question say that what? Solve this using bisection method till you get to what? 0. We'll be doing approximation till you get 0 or something sufficiently small or something related to 0, but it must be 0 when it converge. So it means for me to get my S5 fifth approximation, I have to put this function in this word, in that function I've been given. I have to put my fourth approximation in that function I've been given. I'm going to have f of what? S4. 2 what? 2s. That is the s power of 3 minus what? 2x minus 5. That's f of x. Our f of s is this. So I'm going to put this in this. I'm going to have 2.0625 to the power of 3 minus 2. 2.0625 minus 5. This gives me what? So this one gives the power of 3. I have this. That's 2.0625. So when you are calculating, some students used to make mistake in calculation. So be very careful using calculator. So it's either you, while using calculator, in some places, if you take this out to the power of 3, you first solve this one power of 3, then you now take minus of this, you can get a math error. That is, your answer may not be correct. But once solving this, you have to take it at once while using calculator. It can be cashew, it can be any calculator. But you solve this one as well. And you didn't take this one else, you just multiply it straight. It's going to be confusing you. So if for you to solve this one, you have to press this one. So while you're dealing with this 2 times, you have to use times. And in some cases, you have to use times. That is, you have to multiply this one like this. But if you keep take this raised power of 3, you do this one, this power of, you solve this one also minus 5. It's going to what? It's going to take too much of your time. So 2.0625 to the power of 3 minus 2 times 2.0625 minus 5. So I have minus 0.313 minus 0.351318359. So this is what I get. I can take it to 5 decimal place since I'm not considering this. So it means what? So what next is what? What's giving this? So f of what? 2.0625. So for me to what? For me to get my S5, I have to go and get where my what root lies on. That is a plus b over 2. That is what is my a? That is What I get different is negative, so I have to go to my last positive. So my last positive, where is my last positive? Yes, this is our last positive. In when we are doing f of 2 plus 125, what do I get? I get positive here. So it means what give me this answer? This is positive. Invisible plus invisible sign here is positive. F of 2.125. F of 2.125. So this one will not be my A, and this one that give me negative. My last answer here is be my B. So that is my last positive here is what? A, and the next is what? B. So my f of 215, since f of 2.125 is equal to what? Positive plus V is positive, and f of what? 2.0625 is negative. So the root lies in what? The root lies in the root lies in the root lies on 2.125, which give me positive, and what? And 2.0625. So for me to get my what? S5, I will find the midpoint. That is S fifth approximation is equal to this one plus this divided by 2. You can make screenshot for this. You can make screenshot for this. So my S5 is the midpoint of this 2.125, 2.125 plus what? 2.0625. So my S5 is now what? All over what? All over 2. So I have what? 2.09375. So this is what? My S5. So I want to get what? So for me to get my S's, I have to use the function. The original function that they give me is what? If you it's steps. If you keep doing the steps, you just be doing the step, putting it to there, get your what? Function, then you get your what? The approximation you are doing. So this is my S5. For me to get my S5, so I have to put this function f of x, our S3 minus 2x minus 5. So if this one is what? S5, I'm going to have 2.09375. That is my x5 raised to the power of 3 minus 2, 2.09375 to the minus 5. So I'm going to have what? 2.09375 to the power of 3 minus 2 times 2.09375 minus 5. So what do I have? I have 0.008941650391. That is That's what I have. That is 0.00894 So what's give me this? F of what? What's give me this? 2.09375. 375 give me this. That is 2.09 give me this. To convert this one to what? This one is 00. I have minus okay, minus 0 point is minus 0 point is equal to minus 0 point. So it's give me this. If I don't mind, I can take it to, or I can just take it to what? 4 decimal place. I will just have minus 0.0089. Either way I want it. So since I'm not considering the answer, I'm considering what give me this answer. So it means for me to get my x's, so I have to, since I have negative here, I have to go back to my last positive. So where's my last positive here? You can see that my last positive here is what? What give me last positive here? So this is positive. This is my last positive, which is what? 2.125. You can see that 2.125 is our last positive. That's what, since f of what? 2.125 gave me what? Plus v, which is positive, and what? And f of what? 2.09375 gave me what? Gave me negative. So the root lies between what? The root lies between this 2.125 and what? 2.09375. So for me to get my x's will now be the a plus b over 2. So this is our a, this is our b. 2.125 plus 2.09375. So I'm going to have all over 2. So 2.125 plus 2.09375. What do I have? I have x of 6. S was to 6, that is 6 approximation is what? 4.21875 all over 2. So my S of 6 is now 2.109375. So 2.109375 secant figure. So this is the solution to what? So hence I was told about to find the sixth approximation, successful approximation, sixth successful, that is sixth successful approximation. So I'm going to stop at what? X6. I'm going to stop at what? X6. So the reason why we are solving using bisection method, we have a reason why we are doing it. So it means our work. When we are doing our approximation, we must get at is equal to 0 or sufficiently small related to 0. So it means what? Since the question says that I stop at what? X6. So I will stop at what? 6 approximation. But for us to get our 0 here, I will keep doing it. I will do my X7. For me to get my X7, I have to what? I have to substitute this one into that function and pick it. So that is now it will not determine where to take my what? Midpoint. So for me to get the what? X7. So for us to get our 0 here, why do you do this? I solved it. When I solved it, I did it to what? 15 approximation. 15th approximation. When I get my x, that is my 0, that is 0 point. I think I have 0.001 something. When I got to S12, I got 0.0 something. But when I get S13, I started getting my S0 from S12. So when I did S13 answer is even small. Is even S13 answer is even smaller than what S12. While S12 is bigger. So that's why I keep continuing. So for us to do this one, for us to get this root of this solution, the root of this question, that is S3, S to the power of 3 minus 2 is minus 5. Without stopping at this approximation, I'm going to stop for me to get my 0. That is, the end of doing this was to get our function at 0 or something sufficiently small or related to 0. That is, it is close to 0. I must stop at what? S of 15. You can see that this one is just 2.10. It's not even close to 0. We still have 1. We still have 0.125. So it's not even close to 0. But the concept is that we should stop at x's. So I'm going to stop here. So this is the solution. So my answer that what I should stop at what? I should stop at what? X's. So the root. So the root of the equation. So the root of the equation is 2.109875. So this is the answer. Because my question is that I should stop at what? This is approximation. But if the question is that I was to find the root of this, the real root of this using bisection method, it means when you have to keep doing it till your approximation. That is all this one, I'm doing iteration and my iteration substituting it. You keep doing it till you get what? So you get what? When your answer converge, that is you get what? That is you get what exact value of the what? That is exact value of what? For this one bisection in this one, you have to get 0. But this is what? For me to get this one is what? S to the 15, that is 15 approximation. So it seems because that we stop at S6, that is 6 approximation. So I will stop here. So the root of my equation is this. I hope you find this interesting. Thanks for watching. Please click on the subscribe bell so that you'll be notified whenever I drop a new video. Thank you for watching once again. You can see that my sixth approximation I have 2.1094. So my seventh approximation I have what? 2.1016. My eighth approximation I have 2.097. You can see that my sixth approximation these are what I have what you know that when I have 2.1094 I have 2.1094. But if the question says that what you should find the real root without giving you where to stop, that is approximation that you are going to stop. So you keep doing it till you have a value of 0. See my S8. So let us see S9. So I have what? 2.095 as well. I have on S10, 10th approximation, I have 2.0947. Then on my 11th, I have that is my 12th approximation, my 13, my 14, and my 15. You can see that it ended at addition I now get 2.0946 and I have what 0.0025, that is close to what 0. On 14th approximation I have minus 0.00. On 13 I have 0.00 as well. But on 15 my answer is what 0.0025.